Question number 5. David's planning to build a vegetable garden in his backyard using an existing wall. Sides are 12 metres. Okay, so W plus L must equal 12, which means L equals 12 minus 2W. Go to the area of the rectangle. Okay, area of the rectangle will be length times width, and the length's going to be 12 minus 2W times W, which is 12W minus 2W squared, and that's what we had to show. Done. In part 2, find the maximum possible area of the rectangular garden. Well, I know the area is 12W minus 2W squared, which is 2W outside of 6 minus W. So that is area against W. It's a parabola, it's upside down, as x-intercepts at 6 and 0. Therefore, the maximum will be at 3. Therefore, the area is going to be 12 times 3 minus 2 times 3 squared. 36 minus 18 equals 18 metres squared. If I was to do 12x minus 2x squared and did calculate the max when x goes from 0 to 6, you'll see that the maximum is 18, and that's when x equals 3. Okay. David realises his new vegetable garden must fit within the boundaries created by his garden path. And here's his garden path. Let the existing walls be defined by so that point there, okay. Both x and y have given that g is continuing to find the value of k. Well, the value of k will be the x value when these two things are equal to each other. So 3 log by c of x equals 2 log by c of 12 minus x. Solve for x. So 3 log by c of x, so keyboard ln of x equals 2 ln of 12 minus x, and solve for x. And x equals 4. Therefore, a equals 4, because a is the value when they're equal to each other. So that's 4 and g of 4, and g of 4 will be 3 log by c of 4, or 6 log by c of 2. Show that area, okay, so this area here, length times width, and the length will be the difference between these two x values. So if I make 3 log by c of x equal w, because w is the height, so that's x1w, and this point here is x2w. So that's x1's. x1's going to equal 3 log by c of x equals y. Solve for x. I get e to the w on 3. So that's what x1 is. x1 equals e to the w on 3. and X2 is 2 log base C of 12 minus X equals W. So this one equals W. I'll use a Y for W, solve for X. And that's 12 minus. So that's X2 equals 12 minus E to the W on 2. Therefore, this distance L, so X1, X2, L equals X2 minus X1, which is going to be 12 minus W on 2, E to the W on 2 minus X1, which is E to the W on 3. E to the W on 3. Therefore, the area in terms of W is W times L, which is W times 12 minus E to the W on 2 minus E W on 3, and that's shown. Hence, find the value of W where that is a maximum. Okay, so if I did F max of A of W in terms of W, where W goes from, what does W go from? 0 to 4, because my highest is around about 4. 0 to 4. So I've got X bracket, I've got 12 minus that, minus that one, and I'm replace that with an X, replace that with an X. Close bracket. So I could take this answer and find interactive calculation F max going from 0 to, I think it's 6 log base C of 2. That's the maximum it can be. And I get a maximum value of area equals 15.5203 and W equals 2.4908, and we need 2 decimal places. Therefore, maximum area 15.52 units squared, and W equals 2.09, 2.49. Oops. Can David build this rectangular garden as described, so with 12 metres of timber? So 2W plus L has to be less than 12 or equal to 12, given that W equals 2.49. So 2W plus L, which is 12 minus E to the W on 3 minus E to the W on 2, and all of that's got to be less than or equal to 12. So I've got this term here times by -1 because it took a minus X out. So I've got this term here plus 2X math 3 given X equals 2.49 gives me an answer of 11.21 is less than or equal to 12. Therefore, yes, David can build. And that's the end of that. I'm going to do part C as a separate video.